Right, here we're looking at section 4.4, and our essential question is how can you factor a polynomial? So let's look at our learning targets. The first learning target is factor polynomials, and we'll look at several different ways to do that. And then our second learning target is to use the factor theorem. So here we're going to be factoring each polynomial completely. So let's look at part A first. So the first thing I see in part A is that I have something that's the same, that's common in all three of my terms. So my terms are, right, x cubed minus 4x squared minus 5x. So I notice each of these terms has an x in it. So I first want to factor that out. So I'm going to factor out that x. And I know that I'm left with, I divide each term by that. So x cubed divided by x leaves me with x squared. 4x squared divided by x leaves me with 4x. And this leaves me with a 5. So that's the first step with this one. I'm not quite done yet. So now I know that I need to factor this trinomial, right? And it's a trinomial because it has three pieces. So this one I can go ahead and just simply factor, right? So my x can't go away. I know that the first part in both of my parentheses is going to be an x. And I know that because this leading coefficient, right, the leading coefficient is the first number with the largest exponent. So that's a 1. So both of these are going to be x. The next thing I do is I look at my constant term, this term over here that doesn't have a variable, and I figure out what are all of my possible factor pairs to get negative 5. Well, I could multiply negative 5 times 1. I could multiply 5 times a negative 1. Both of those will get me negative 5. I don't have any other factor pairs to get to 5. So now that I've listed my factor pairs for my constant term, I can find which set of those pairs will sum or add to this middle term. So I see here this negative 5 times 1 will add to get me negative 4. So now I can go ahead and place those here, my negative 5 and a plus 1. So now I want to double check and look to make sure that I've factored this completely. So I see that I have. Everything is left with one single piece. So this first part has been factored completely. So now let's look at part B. All right, so B, I have 3y to the 5th minus 48y cubed. So the first thing I notice is I see I have some y's in both terms, and I know that 48 is divisible by 3, so I can factor out a 3 as well. So I'm going to factor out 3, and I know that I can factor out 3 y's, y cubed. So here in my first term, I'm left with y squared minus, all of my y's are now gone out of the second term, but I know that 48 divided by 3 is going to be 16. So here I'm almost done, but not quite. So I want to look here and see what I've got. So here is what we call the difference of two squares, right? So we've seen this before as the difference of two squares. So I know that I know what the square root of y squared is, and I know what the square root of 16 is. So I can rewrite this as my 3y cubed doesn't go away. And I know that when I'm dealing with the difference of squares, I'm going to write it over here in a different color. My difference of squares tells me, right, a squared minus b squared. So first I'm subtracting. I've got the square root of something, the square root of something. That will end up being a plus b times a minus b. This is just one of my patterns that I can notice and I can use often. So from here, going back to our problem, my a was y. So I'm going to end up with y, and I know that the square root of 16 is 4, so I'm going to end up with y plus 4 and y minus 4. Okay, so now I am fully factored. Everything has been separated as much as it can. So now let's look at part C. I've got 5z to the 4th plus 30z cubed plus 45z squared. So this again, I see I have a z term in each of my terms, and then I can also factor out that 5 in each. So I'm going to factor out a 5z. So here, I'm actually going to factor out 2 z's because I have a z squared, so it's going to be 5z squared. So here in my first term, I'm left with z squared plus 5 goes into 36 times, and I'm left with 1z. And then 5 goes into 45 9 times, and that z has been taken care of. Okay, so now I'm here. And now this looks more like part A. So again, I can factor from here. So my 5z squared doesn't go away. but I know that I'm going to end up with two binomials from this. And I know that the first term in each of those is going to be z because my leading coefficient is 1. So now I come up with all of the factor pairs to get me a positive 9. Well, it can be 9 times 1, or it could be 3 times 3. And I know that either they both have to be positive or they both have to be negative to get that positive 9. So now I look for the pair that will sum or add to this middle term, which is right here. So I can add 3 and I add 3. So I see that these two are the same thing, right? I have z plus 3 and z plus 3, so I can just rewrite this as 5z squared times z plus 3 squared, because z plus 3 times z plus 3 is z plus 3 squared. So now I have fully factored this one. Okay, so now here are a couple that I want you to try following the same kind of patterns that we did in those last examples. So here's our new core concept. We're going to be looking at special patterns, right? So here's the sum of two cubes, right? Just like our difference of two squares that we've looked at before, we're looking at the sum of two cubes. So if I know the cube root of A and I know the cube root of B and I'm adding them, here's the pattern that I'm going to follow, right? And this will always work. So here's an example of this. So 64x cubed plus 1. Well, I know that the cube root of 64x cubed is 4x, because 4x times 4x times 4x gives me 4x cubed, 64x cubed. And I know the cube root of 1 is 1. So now I can replace the things that I know. So I end up with 4x plus 1 times the quantity 16x squared minus 4x plus 1. So then I have another factoring pattern, which is the difference of two cubes. So if I'm subtracting in between here, here's what I'm going to end up with. And you'll notice the only main difference is where my negative sign ends up. And this will come into play a little bit later. So my example, right, 27x cubed minus 8. Well, I know the cube root of 27x cubed is 3x, and the cube root of 8 is 2. So now I can fill in what I know from this. So now let's look at an example using those. Okay, so this is example 2 in our book. So here is, let's look at part A, x cubed minus 125. So first thing I notice is that I'm subtracting, and I know the cube root of the first term, and I know the cube root of the second term. So let's go ahead and write it that way. Well, the cube root of x cubed is x, and the cube root of 125 is 5. So now I have my a and b values. So now I can go back to my core concept, and I can look at how I'm going to write those out. Okay, so I know that I'm going to end up with my a minus b, so my x minus 5, and then I have a squared plus ab, or ba, right? So I always just write them numbers first, plus b squared. So now I'm left with this. And that's as simple as I can get that, and that's as factored as that will work. So I know that I'm done with part A. So let's look at part B. I have 16s to the 5th. And this is hard to keep s's and 5's separate, so try your best. Plus 54s squared. So the first thing I notice is that I can factor out a couple of things. I've got an s squared in both of these, and I can also factor out a 2. Both of my terms can be divisible by 2, so let's go ahead and factor out that 2s squared first. So then I'm left with 8s cubed plus 27 once I've factored that out. So now I see I have a plus in between here, but I also have some cubes, so I can find the cube roots of things. So my 2s squared doesn't go away, and I know that the cube root of 8s cubed would be 2s cubed, right? And I'm going to put this in brackets. And I know the cube root of 27 is 3. Okay, so now that I have my a and my b, I can go back to my core concept and look at my sum of cubes pattern to see how I'm going to finish writing this out. So my 2s squared doesn't go away. It's still there, but then I know that I'm going to have my a value, which was 2s, plus b, which was that 3. Then I have my a squared, which is going to be 4s squared, because 2s times 2s is 4s squared. And then here's where my subtraction comes in with my sum of cubes, and I multiply these two things together, so it's going to be 6s plus 9, my b squared. So all I've done here is I've taken my a, right, and this 2s is my a, and this 3 is my b. So now that I figure out what my a and b are, I can go back and use these patterns to get me there. So now I look and I double check, and that's as completely as I can factor it. So now we're going to be factoring by grouping. This is example number 3. So you'll see here I have a larger polynomial. I have 4 different terms in my polynomial. So here I'm going to be grouping things. Okay, so I'm going to just rewrite it here. Z cubed plus 5z squared minus 4z minus 20. And so there's not something common that I can take out of every term, so I can't start there. So now I'm just going to group this. So one thing we want to do when we're grouping is make sure that I don't lose negative signs. And in order for me to keep that straight in my mind is I go ahead and make everything a plus. So it's going to be z cubed plus 5z squared plus a negative 4z plus a negative 20. So now that I have plus, I'm just adding. Now I can go ahead and group in any order that I need to. So I'm going to go ahead and group my first 2 terms and my last 2 terms. And I'm going to group them that way because I see I can pull out some z squareds from my first 2 terms, and then I see I have a number or a value that I can factor out from this second set of terms, okay? And that'll come into play later. So I see in my first set of terms that I've grouped, I can pull out z squared. So let's go ahead and do that. So I've got z squared, and what's left is going to be z plus 5. And then I add. And so here I see I can pull out a negative 4. So I'm going to pull out that negative 4, and what I'm left with is z plus 5. Here's why I grouped that way. Whenever I'm grouping, the things that are left inside my parentheses have to be the same thing. So here I could see that I would pull this out and I'd end up with a 5 here. So now that I've grouped them this way and I've pulled those out, I take the 2 things that I pulled out, so my z squared minus 4, right? Or it could be plus a negative 4. Either way, those are the 2 things I've pulled out. And then I have my parentheses, the things that are left, z plus 5. So this is really dealing with, we've done the distributive property very often, right? So I would distribute this. This is kind of undoing the distributive property to get to here, right? From here to here is still the distributive property. So before I consider myself completely done, I look back and I see if there's anything else I can do. And I see here I have a subtraction, and I have 2 things that I know the square root of. So this would be my difference of 2 squares. So I know that this first binomial is going to become z minus 2 and z plus 2. And this last z plus 5 just stays the same because it can't be factored any further. So now that I'm here again, I double check, make sure there's nothing else I can factor before I'm completely done. Okay, so now we're going to be looking at some quadratic forms. So this is example number 4. So here, let's look at A. I've got 16x to the 4th minus 81. So 16x to the 4th minus 81. So the first thing I want to do is I see if there's any common value that I can pull out of both terms, which there's not. But I do notice that I'm subtracting, and I know the square root of both of these, so this is going to be my difference of 2 squares. So I first want to write it out as my difference of 2 squares. So I know that 4x squared gives me 16x to the 4th minus 9 squared, right? So now I have an A and I have a B. So this is going to be my A, and this is going to be my B. Now that I've written it so it's my difference of 2 squares. So now I can just go ahead and use my difference of 2 squares patterns and write this out. So I'm going to have 4x squared plus 9, and I'm going to have 4x squared minus 9. So I double check, make sure I can't factor anything else. But I see here in the second polynomial that, again, I know the square root of this first term, and I know the square root of the second term, and I'm subtracting. So again, I'm going to use my difference of 2 squares. So my first part stays the same. So 4x squared plus 9. This is going to become 2 pieces, right? And I know that one's going to be a plus and one's going to be a minus. And I know I have to first find the square root of the first term. The square root of 4 is 2. The square root of x squared is x. So the first part becomes 2x for both of these. The square root of 9 is 3 for both of these. So again, I just double check, make sure there's nothing else I can factor before I'm completely done. So now here, yes, I have a subtraction here, but I can't take the square root of either of these pieces, so I just leave it that way. So now let's look at part B. So I've got 3p to the 8th plus 15p to the 5th plus 18p squared. So the first thing I notice is that each of my terms is divisible by 3. So I'm going to factor out of 3, and I see that each of my terms I can get rid of some of these p values, right? So I'm going to get rid of 2 of the p's. So my first term of my polynomial, I am left with p to the 4th, p to the 6th, plus 5, and here I'm left with 3 p's, and here I am left with 6 once I do my division, right? So now here is something else that I can factor, right? And we've looked at squareds and then like 1x and then a constant. We're going to do something very similar here. So I end up with 3p squared. It doesn't go away, right? And I know that this I can factor. So instead of just an x here or a p here, it's going to be p to the 3rd. And I know that that works out because that is the middle term. It has a p to the 3rd. So now again, I find all my factor pairs of 6. So it can be 6 times 1, or I can have 2 times 3. And they're either both going to be positive or both be negative. So now which set of pairs, which set of factors adds to 5? Well, it's the second one. So I'm going to have p cubed plus 2 and p cubed plus 3. So now, before I go any further, I double check, make sure I can't use any of my other patterns or properties. So I know, I looked back here, I do have a sum of 2 cubes that I might have, right? Because I have p cubed. But I don't know the cube root of 2 and I don't know the cube root of 3, so I can stop there and I say that I am fully factored. So here are a couple of more monitoring progress that I want you to try out. So now we're going to look at our factor theorem, right? This was our second learning target of this section. So I know that here's my factor theorem, that a polynomial has a factor of x minus k if and only if f of k equals 0. So I know that this k value, this becomes a factor, right? And a factor is something I can multiply something else by to get there, if I put that k in and the whole thing is 0. So this is kind of worded strangely, so let's look at an example of this. Okay, this is example number 5. So determine whether x minus 2 is a factor of f of x equals x squared plus 2x minus 4. Okay, so we're going to stop there for now. So the first thing I want to do is I can do this by direct substitution. So I figure out what would make this part 0. So what makes x minus 2 0? Well, I add 2 to both sides, so I get x equals 2. Makes this first part 0. So now I'm going to use just direct substitution and see where I get. So anywhere in my larger polynomial, I see an x, I plug in that 2. So I've got 2 squared plus 2 times 2 minus 4. Well, 2 squared is 4, plus 2 times 2 is 4 minus 4. So 4 plus 4 is 8, minus 4 is 4. So here I'm left with something. And this is not 0, right? If this was 0, then yes, this would be a factor. So this, since this is not 0, this is not a factor. So I can go ahead and say no, that is not a factor. Okay, so let's look at part B. So we're seeing if x plus 5 is a factor of 3x to the 4th plus 15x cubed minus x squared plus 25. So right, in part A I use direct substitution. In part B I'm going to use my synthetic division. So I have to figure out what would make this 0. So x plus 5 equals 0 minus 5. So if x is negative 5. So let's try that. So again with synthetic division, that is what goes out here. And then I have to fill in my terms, my coefficients from all of my terms in my polynomial. Right, so I'm going to have 3, 15, negative 1, 0, and 25. I can't leave out the 0 because I don't have an x term, so I have to give it a value. Right, and when I'm using synthetic division, I take down this first term, and then I just start multiplying. So negative 5 times 3 is negative 15. 15 minus 15 is 0. Negative 5 times 0 is 0. Negative 1 plus 0 is negative 1. Negative 5 times negative 1 is 5. 0 plus 5 is 5. Negative 5 times 5 is negative 25. 25 plus a negative 25 is 0. So this is what I'm looking for here. Since this number is 0, then I can say, yes, this is a factor. So I can either use direct substitution or I can use synthetic division to determine if it's a factor. So, and it always comes down to what I'm left with at the end. If I'm left with some number, then no, it is not a factor. But if I'm left with a 0, then yes, I am looking at a factor. So we're going to look at example number 6 here. So show that x plus 3 is a factor of this polynomial, then factor completely. I personally like to use synthetic division because it saves time down the road. So I need to figure out what I am using. So I set this equal to 0. I subtract 3 from both sides, so x equals a negative 3. So a negative 3 goes in my box. So my values up here is 1 is with my x to the 4th. I have a 3 with my x to the 3rd. I don't have an x squared term, so I have to plug in a 0 for that. Negative 1, and then negative 3. So now let's go ahead and do my synthetic division. I bring down that 1. Negative 3 times 1 is negative 3. 3 plus a negative 3 is 0. 3 times 0 is 0. 0 plus 0 is 0. 3 times 0 is 0. Negative 1 plus 0 is a negative 1. Negative 3 times a negative 1 is 3. 3, here we go. So here, since this is a 0, yes, this is a factor. So here I have showed that it's a factor. So now I can rewrite my polynomial, right? So this was my remainder, so here's what I'm left with, right? So this would be my constant. So I know that I'm going to have x plus 3, because that's what comes from up here, right? So then let's see what I'm left with. I'm left with my constant as negative 1. I don't have an x term, I don't have an x squared term, but I have an x cubed term. Okay, so now that I'm here, I see, oh man, I've got the difference of 2 cubes, so this can be factored further. So my x plus 3 stays there, and then following my difference of cubes pattern, which you should have somewhere where you can get to it fairly quickly, I'm going to end up with x minus 1, and then I'm going to have x squared plus x plus 1. And now I can double check, make sure everything is factored completely, and I know that it is here. So the first step that I did was show that it was a factor, and I did that because my remainder was 0. Then I can rewrite my polynomial, what I'm left with after dividing, and I can completely factor from there. So now let's look at our real life example. Here's example number 7. So during the first 5 seconds of a roller coaster ride, the function h of t equals 4t cubed minus 21t squared plus 9t plus 34 represents the height in feet of the roller coaster after t seconds. How long is the roller coaster at or below ground level in the first 5 seconds? So here's what we have to do. First thing, we want to understand the problem. So I'm given a function rule, and I'm asked to determine how long it's at or below ground level during the first 5 seconds. So first thing I did was I made a graph to estimate my zeros, and then I can check that using the factor theorem. Okay, so from the graph, my 2 zeros appear, a couple of them appear to be at negative 1 and 2. My third 0, right, is at a weird decimal or fraction, so I don't know exactly where that's at. So first I'm going to try negative 1 and see if that works using synthetic division. So I pull out my negative 1, right? 4 minus 21, 9, 34. So once I do my synthetic division, I end up with 0. So yes, this does work, and t plus 1, right, becomes my factor. So now I can determine if 2 is a 0. And again, I start with my values from above, right, that I found here, and I continue my synthetic division. And again, my remainder is 0, so t minus 2 does work as a factor here as well. So now I'm left, I have my t plus 1, my t minus 2, and now I'm left with 4t minus 17. Those are the values left. So 4t minus 17 indicates that my 0, right, I could set this equal to 0, is at 17/4 or 4.25. And that's why I couldn't find this one right off the bat. So here's my zeros, right? -1, 2, and 4.25. So, but I really only care about this t equals 2 and t equals 4.25 because I can't have a negative time, right? So I don't care about this 0 that's in the negative. Okay, so and this shows that my graph, right, between my 2 is underground or at below 4.25 minus 2, so 2.25 seconds. Okay, so the distance from here to here is where it was underground, as shown in my graph as well. So I can just subtract those 2 zeros and it'll tell me how much time. If I want to, I can use a table of values in my calculator to also see what happens between those zeros. Okay, so now here's a couple more monitoring progress for you to try out and see if you can follow along and get those done. So let's look back at our learning targets before we move on. Okay, so our first one was factor polynomials. We're going to factor those using just general factoring. We look at difference of squares, we look at difference of cubes, and we look at sum of cubes. Those are kind of the big patterns we need to look at. And then our second learning target was use the factor theorem. Can we tell if something that we're given is an actual factor of our polynomial? And we did that using several different methods and in several different ways. So now I want you to go ahead and work on your homework practice, your problems for 4.4.